Hi guys, so today we're going to talk about drawing loose dot structures and Vesper theory. So basically atoms bond together so that they form low energy compounds, and so the lower the energy the more stable they are, and so we're trying to draw these in terms of low energy. When you are drawing low dot structures, you got to keep in mind that low energy means that you would want to follow the duet or the octet rule when possible, but just be aware that sometimes you have expanded or less than an octet. So how would you do this? The correct way to do it is to draw your valence electrons, move them around so that you can give everybody their duet or octet. So for example, hydrogen has one valence electron. So you draw your valence electron. Now once you've drawn your valence electrons, you can move them around. So if I had drawn it here, I could move it around and to there. So, you know, the electrons can move around if they are bonded. So once you draw your valence electrons, you connect everything once and check that everybody has an octet or a duet. And so if you remember, most elements want or would be stable if they get an octet, meaning 8 valence electrons. Hydrogen, though, is okay with a duet with just 2. And electrons that are in a bond count for both of the atoms. So this hydrogen has 2, this hydrogen also has 2. For oxygen, oxygen has 6 valence electrons each. 3, 4, 5, 6. And so you connect one set and you count. So for this oxygen right now, you have the 2 that are in the bond. So 1, 2, and then 3, 4, 5, 6, 7. Same thing with this one. It also has 7. So since they both want more, you can bond a second pair. And now this oxygen has 1, 2, 3, 4 that are in the bond, and then 5, 6, 7, 8. This one also has 8, so that's good. So then when you're done, just make sure it looks a little bit neater. Put your lone pairs next to each other. They exist in pairs, so this would not be okay on the test or on a worksheet. Notice that I try to put my electrons as far away from each other as possible. So I have my groups of electrons, since I have 3 groups here, at 120 from each other. You don't have to do that, but if you get in the habit of doing that, then you're more likely to get your shapes and your polarity and all that correct. PF3, so phosphorus has 5 valence electrons, 1, 2, 3, 4, 5. It bonds to 3 fluorines, and each of the fluorines has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. And again, you can put them anywhere that you want. 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then you bond everything once. And now everybody has an octet. So that's pretty good. We'll practice some more of these. Vesper theory. So Vesper theory says that valence shell electron pair repulsion theory. So it says that the electrons that are in the valence shell, so the valence electrons, the ones in the highest energy level, exist in pairs and they repel each other. So because those electrons that are in the valence shell exist in pairs and repel each other, that means that each pair of electrons are pushing all the other pairs of electrons away, as far away from each other as possible, because they repel each other. And because of that, that determines the geometry of the molecule. So it all has to do with the groups of valence electrons and them pushing each other away. Now we have electron geometry and we have molecular geometry. On the AP exam, I haven't seen them ask about the electron geometry at all. So when they ask for geometry, usually it's the molecular geometry that they're looking for. For me personally, though, I think it helps if you know the electron geometry, so that from that you determine the hybridization, the bond angles, and the molecular geometry. So for me, it helps me if I know what the electron geometry. And again, that is the geometry or the shape that the electrons make, versus this one is the shape that the molecule makes. And so the difference here is lone pairs. If all of your electrons, your valence electrons, are in bonds, then the electron and the molecular geometry are going to be the same. The shape of the electrons will be the same of the bonds. But if you have lone pairs, then the shape of the electrons will be different from the shape of the bonds and therefore the molecule. So something to look at here. Now let's look at the bond angles. So if you have your central atom, basically the first thing that I do after I draw my Lewis dot structure is I count how many areas of electrons I have, and that helps me come up with the bond angles, with the hybridization, and then later on with the shapes as well. So let's say that your central atom has 2 areas of electrons around it. The farthest you can put 2 things away from each other is 180 degrees. And so the bond angle would be 180 degrees here. Let's say you have 3 areas of electrons. So you want to put them as far away from each other as possible. The farthest they could be is 120 degrees from each other. And so the angle that the bonds make would be 120. Let's say you have 4 areas of electrons. So if you remember, it kind of looks like a tetrahedral like that, with the angles being 109.5 degrees apart. Now, if you have 4 areas of electrons, but one of them is a lone pair, so it kind of looks like that, the angle is just slightly less than 109.5. It's about 107 or 107.5. If you have 4 areas of electrons, but 2 of them are lone pairs, so it looks like this. Those lone pairs, again, push a little bit on that angle, and so they bring that angle a little bit closer, and so it's actually 104.5 or 105 degrees. Now, this part is just for your notes. So when you go to college, you will be responsible for knowing this. On the AP exam, you do not need to know these angles. As long as you have 4 areas of electrons, you just stick with the 109.5. So no need to remember those for the AP exam or for my test, just for college is why we have these here. But you just go with 109.5 for the AP exam for 4 areas of electrons. If you have 5 areas of electrons, so if you remember, you have 1 up, 1 down, and then the other 3 kind of make like a peace sign that are 120 degrees apart. So you have 2 sets of angles here. You have 90 degrees, and then you also have 120 degrees. For 6 areas of electrons, if you remember, you have 1 up, 1 down, and then those 4 are in a one plane. They make like a plus sign almost. All the angles here are going to be 90 degrees. And in my next video, I'll show you all these shapes and go over the bond angles together, where you can see them. 7 areas of electrons. So that would be 1 up, 1 down, and then you have 5 that are in the plane. And so the angles, you have 90 degrees, but then you also have 72 degrees. And again, we'll look at those in the next video. Let's talk about hybridization. So hybridization is where your orbitals mix together. Just means mixing of orbitals. And in a later video, I'll show you what all that means. But basically, if you have, let's say, carbon, and we know it has 4 valence electrons, we know that the first 2 go in the s orbital, and then you have the others go in the p orbitals. If you remember, s looks like a sphere, p looks like dumbbells, right, in the x, y, and z plane. In order to bond it to 4 hydrogens in CH4 here, you would have to move your, you have 2 here, you'd have to move one of them there in order to bond it to, each of the 4 hydrogens. And so that's fine, but we would expect that, those are s electrons and these are p electrons. Some look like spheres, some look like dumbbells. Their electron density or their, probability map, I should say, looks like a sphere or dumbbells. But in reality, it turns out that all 4 of these look the same. Their electron density looks the same, and they look like kind of hybrid between an S and a P like that. And so they said, oh, it looks like these 4 orbitals mixed together, and since there's an s orbital and 3 p orbitals, we're going to call that hybridization sp3. So each of these orbitals is an sp3 hybrid. We're going to talk more in detail about hybridization in a later video, but here's how you figure out what the hybridization is. If you have 2 areas of electrons around you, around your central atom, I should say, like here's carbon dioxide. So if you look at your central atom, there are 2 areas of electrons here. There's an area of electrons and there's an area of electrons. That tells us that 2 orbitals have mixed together. And so the first orbital is an s, and then the second orbital is a p. So it's an sp hybrid. Let's look at the next one. So there's CH2O. And you count how many areas of electrons are around your central atom. So my central atom is the carbon. There's 1, 2, 3 areas of electrons. And so that means 3 orbitals mixed together. The first one is always an s, and you can only have 1 s orbital. Then you get to your p's, and if you need 3 orbitals, one of them is an s, then the other 2 would be p's, so sp2. So 3 orbitals mixed together, 1 s and 2 p's. NH3 I'm going to do here. Looks like this. And so if you count how many areas of electrons are around it, there's 1, 2, 3, 4. So that means 4 orbitals had to mix together. The first one's an s, and then the other 3 are p's, so it'd be sp3. Now that's all you need to know for the AP exam, up to 4 areas of electrons. We will put these in our notes because in college up till now they still teach them, even though they've proved that this doesn't really happen. But just so you have it in your notes, we'll do them together here. So if you have 5 areas of electrons, that means 5 orbitals mixed together. So you have an s, you can have up to 3 p's, and then you'd need a d, so that there will be 5 total orbitals. SH6, you have 6 areas of electrons around that sulfur, so you need 6 orbitals. So you have an s, you can have up to 3 p's, and then you'd need 2 d's. And then Cl H7, 4, 5, 6, 7, it looks like that. Chlorine has 7 valence electrons, each is bonded to a hydrogen, and so you have 7 areas of electrons, so you have an s, 3 p's, and then 3 d's all mixed together. Again, there is no such thing as a d orbital hybridization, so these don't really exist, and so they're no longer on the AP exam. I just put them here in your notes, just in case when you go to college they are still teaching these hybridizations. But for my test and for our AP exam and semester exam and everything, we're only going up to sp3, so you just need to know sp, sp2, and sp3 hybridization. Okay, in our next video, we're going to talk about all these different shapes and their hybrids and their angles and all that good stuff.